square keyboard here, we can go to numpad and punctuation, I believe. Let's try that one real quick. So this one now has, not that one. Decimal pad, there we go. Decimal pad has the decimal point. It will not prevent you from malformatting. Here, let's see. So you could now, you don't have A, B, C, D, so you don't have letters, you just have the regular numbers and a decimal point, but you still have to check because someone could do this. So that's not a valid number. So yes. Yeah. Yeah. Well, so theoretically, so I guess, oh yeah, so good point. So how could we help with that? So, well, one thing, we could add a label, enter percent, I guess. So percent implies that it has the 100 in it. There's another word for the percent without the 100. I forget the name. Does anyone know what the name for a value that is supposed to present a percent, but it's from 0 to 1 for like 100%? Does anyone know? Yeah, there's a word for it. I don't know it. But yeah, so if I'm hearing percent, I would type in 15 for 15% tip, right? I think most people would do that. And then, I mean, you could guide the user. If it's something nonsensical, you could, as the user is typing, you can say, or like as they're trying to apply, you can say, hey, this looks weird. Is this what you wanted? But yeah, I don't think you can restrict the user from doing it. Because maybe, so I think I mentioned this, if you get a German, they might want to give you a 0.1% tip. So did I mention this here? I'm originally from Germany, so it's whenever my dad is visiting, he will give 10 cents tip. He will round up because so in Germany, waiters get a living wage, and so the tip is there if you're doing an extraordinary amount of work. Most people, well, if you're a really good server, they will round up. So that's the tip that people will give. So I've had to many times, and my dad will sneak away and try to pay by himself, so he doesn't have to give 15% tip, because culturally it's just very different. So yeah, a German might want to type in 0.1% tip. So yes, yeah. Anyways, yeah. So okay, what are we still needing to do here? Okay, so we have a way to talk back to our delegate. We're going to have to change this a little bit to make this reusable, and right now we also have a memory leak here and how we created this. But we'll see that much later. So I think one other thing that we can quickly do here, just for this to work a little bit better, I think one thing that is annoying right now is we have to hit apply and then go back. So wouldn't it be nice if someone hits the apply button, we can also dismiss. And then here we can say, do we want this to be animated? Yes. Okay, so now if we build this, we have, so if we go here, if we hit apply, oh, it should dismiss. 1 second. What am I missing here? Is it not dismiss? Okay, I'm blanking on the. I will come back to you. Should be dismiss. Oh, is it? We're in the navigation controller. That's why. Okay. Might be this. Nope. Oh, is it this? it might be this. Apologies. My UI kit is getting rustier with each year. Being away from it. So let's try this real quick. There we go. Okay. So we have this in a navigation controller, as we saw here. Had we not done that work, so if you're in a modal, this dismisses a modal. I'll leave you guys this. Modal. And then here, when we're in a navigation controller, we can pop back to the previous view controller that we came from. Does that make sense? So if we're applying, we're now going to let our delegate know that something happened, and then instead of having to hit back, we can now pop back to the screen that we came from. Okay, so that's one thing that's nice. Now, the other thing that we probably want to do is we want to show the current percentage. So let's do that real quick. Calculation view controller. We have our, so when our view loads, we probably want to show what the percentage is. So let's do that. So we have our, so we don't have an outlet for that yet. So this is an interesting case where we have an action for this button. So we have, we don't even have an action because we removed it. So we could have an action, but this time we also want an outlet for this button so that we can change the text on it. So let's do that real quick. So here we have our button. Let's control drag. Let's create an outlet. Change tip button. So we want outlet. We don't want action because we want to be able to set the title of this thing here. So one place where we want to set the title is when the app launches. So we have our set tip. What did I call it? Change tip button. So what I find a little bit frustrating is there is a title label that you could set. Sadly, this doesn't update the title. There is a title label. It has a text, but somehow the way that the button was constructed, it doesn't trigger an update of the actual text. So the way that we set a button's title is set title, and then here we're doing the tip formatted as percent. Let me move this. And then for a specific state. So let's take a look at what those states are. So there's normal, highlighted, disabled, selected, focused, application, and reserved. The only ones that you'll ever see really is normal and disabled. So you could have a different button title for a disabled button. I have, in my entire career, I've only ever set the normal title. So for each of the buttons possible settings, you can set a title. So yeah, now when we're loading the app, if we're launching the app, we will be, once the view has loaded, we are now updating the percentage here. And then where else do we have to update it? Say it again. So where else do we need to update this button? When do we have to update it?
Oh, after we return.
Very good. And then since we have the same thing happening twice, this might be a nice little function that we can rip out. So let's maybe call this update tip button. And then we can move that in there. And then if it ever changes, it'll update in both places. Okay, let's test it. So let's set it to 100, apply. 100%. 10%. 10%. Okay. Any questions so far? Okay. So let's just really quickly draw what we've done so far. So we have our calculate. So maybe we'll abbreviate here. So we have our calculate view controller. We have our tip view controller. So when the calculate view controller transitions to the tip view controller, so this is in prepare for segue. So in prepare for segue, the calculation view controller sets itself as the delegate, and then I was saying I was going to use pink for the noun. It sets itself as the delegate on the tip view controller. Okay, so now inside the tip view controller, the user will update the tip. Okay, let's maybe number these. So 1, 2. User will what's going on? Press apply, and then now we have to talk back, right? So we have to talk back to our we report back to our delegate. And what are we reporting back? We are calling, what did we call it? Tip changed to. Tip changed to. So now we're calling, yeah, let's maybe move. Calling tip changed to. Okay, and then the calculation view controller in response will update. I have trouble writing today. Update its tip. Okay, hopefully that makes sense. So calculation view controller has to set itself as the delegate as it's delegating this task. So how do we do it? As we're transitioning to the tip view controller in the prepare for segue, we set ourselves as the delegate. Inside the tip view controller, we do our thing to get the updated tip from the user. Once the user hits apply, we have to talk back to our calculation view controller, and we call on it tip changed to, and then the calculation view controller can update. Does that make sense so far? Yes. Yeah. For what? Yeah. Why did we set normal? This part. So the button has several states. These are the states: highlighted, normal, disabled, selected. The only ones I have ever seen is normal and or ever really used is normal and disabled. So if the button gets disabled, you can set is enabled to false, then it's disabled. So now its state is disabled, so then that title will be used. So I kind of think this should be like a default parameter value. I think that would have been nice. But yeah, so it's just the syntax. So set title string for normal sets the button title. It's just how sadly it's done. Yes. So right now, the way we have it, you cannot destroy either, really. So we currently have a memory leak. We will cover that. Very good question. But so we will not be able to resolve this until I'll show you what to do, but we won't explain it until much later. Say it again. Mounting? No. Yeah. So this. Yeah. I'm not. I'll just give you the answer, and then probably one of the last lectures we'll go over memory management. But yeah. So any other very good questions? Any other questions here? So one thing we are doing right now that violates our MVC pattern. So what we are doing right now is, so let's draw what's going on here. So we have our controller up here, we have our model, and we have our view. So I think I briefly mentioned this. If a parent view controller is talking to a child view controller, we can so we have the child view. So if this is our tip calculation, our calculation view controller, and then this is our tip view controller. So in this case, we can kind of treat the tip view controller as a view for the calculation view controller. So in this case, we are, oh, here, let's do this. In essence, this is what we are doing right now. So our calculation view controller, and let's maybe move this down a little bit as well. So our calculation view controller has as one of its, and I guess it has another view in there as well, but so as one of its subviews, because it's delegating this thing to the tip view controller, we can kind of think of it as the calculation view controller is treating the tip view controller as a view. If we're adding our ways that we are allowing communication, so let's follow the communication that we have here. So who knows a place where the calculation view controller talks directly to the tip view controller? Where are we directly asking it something, or telling it something, or setting something, or can you guys think of any place where the calculation view controller talks directly to the tip view controller? I think not. I think, yeah. Other ideas? Very good. So right here, the calculation view controller is talking directly to the change tip view controller. So we're doing this right now. So this is in prepare for Segway. We set ourselves as delegate and set the tip. Okay, so we have some direct communication going on, and move this guy. Okay, let's move it so we have more space for the other thing. Okay, so in prepare for segue, the calculation view controller is talking directly to the tip view controller. Who can think of a way, of a place where the tip view controller is talking to the calculation view controller? Where are we doing that? Very good. So we have the apply button. Here we're talking to our delegate. The delegate is of type calculation view controller. So right now, the tip view controller, since we have a property that is of type calculation view controller, right now the tip view controller is talking directly to the calculation view controller. So in MVC, this is not allowed. In MVC, we are supposed to use some sort of a restricted communication path. Does anyone remember why? Why do we not want to have direct communication from, in this case, the view to the controller? What were some reasons for that? Very good. So maybe our tip, here, what do we have here? Maybe this is such a great component that we've built. I mean, we're not showing a percent sign, so maybe we want to reuse this as a generic get number from user screen or view. So we can't do that right now. Why? Because our delegate is the calculation view controller. So right now we can't reuse this. And then an added complication is, so the more you create tightly coupled connections like this, where everyone knows everything about it, debugging becomes more difficult. You might be tempted to ask or tell the calculation view controller something that has nothing to do with tip changing, and then it's really difficult to find if there's a bug in that, to find that. So it's very tempting to do more in this method here than what we're intending, or in this view here than we're intending to do. So right now we're violating MVC by talking directly back to the tip view controller. So how can we create some structured communication here where the tip calculation view controller knows as little as possible about the calculation view controller? So what does the tip view controller need to know about the calculation view controller? What does it really only need to know? What's the only thing it needs to know about it? What does the change tip view controller need to know about its delegate, about the calculation view controller? So, so we have a tip here. We have all these all these outlets. We have a button, the action. We have view did load. We have prepare for segue. We have tip changed and update tip button. About all of this stuff does our change tip view controller, what does it only need to know? Of all of this stuff here, what does this change tip view controller only need to know? It has something to what? Yes, how are we sending it back right now? Tip changed, okay. So the only thing that we need to know about our delegate is that the delegate has this method, right? We don't need to know anything else. Okay, so how can we hide the rest of the calculate view controller from the change tip view controller? Does anyone have an idea? Any ideas? So I like that approach. Yeah, we could do a model. That's interesting. So we're going to play with types, and we're going to use something similar to how the destination, how we could have multiple kinds of destination. So any thoughts? So we haven't covered it in this class, but from other languages, can you think of something that can make it so that we can strip all of the information away from the calculation view controller except this method to this change tip view controller. So this change tip view controller, the only thing it's going to know about its delegate is that it has this function. Okay, yeah. That's an idea. So let's see if we can do that. I actually don't know. So we cannot make. So we cannot make prepare for Segway private because the operating system needs it. I like the idea though. That was great. Anything else that you've encountered? So yes, something. So we have to do something with this. Very good. Yeah. Oh, okay. Oh, I love that. Yeah. So we could do this, and then but so yeah. Then we have to kind of check if it has this, right? So how would we check that it has that? So right now, the only way to check that would be to make sure that it is of this type, right? But I love where you're going. So that was great. So you're almost there. Yes, that's really, really, really close. So if we don't want to have an entire class of something, what other things do we have access to? Say again? Interface. Very good. Yes. So interfaces in Swift are called protocols, but it's the same thing. What's an interface? What's a protocol? Yes. Yeah, very good. A way that I like to describe it is it's a contract. So yeah, let's do that. So how do we name this contract? So first of all, let's create a protocol. So protocol interface. So you guys mentioned interface. So in Swift, interfaces are called protocol. Okay. So we have a protocol, and then the way that we want to name it is so that it is very descriptive of this delegate property here. So we want to be able to, so things that we want to capture about this whole situation is that it is a delegate. So most delegate protocols will end with delegate. Delegate. There we go. So that'll be the end. So there's going to be some stuff in front of this here. And what else? What else would describe this interface, this protocol? So so we're being delegated the task of changing a tip, right? So maybe for now just let's do change tip delegate. So I think that's good for now. And now we can say, so in this protocol, we can describe what our delegate should be able to respond to. So our delegate, we should still be able to do this, right? So I'm just going to copy this thing over here, func, and then let's turn this into a double, new tip. Okay, so our delegate should be able to respond to this thing, right? Okay, so on this end, I should now be able to exchange our calculation view controller type with change tip delegate type without anything breaking on this end, right? So on this end, everything should still be okay. So on this end, we're going to have some issues here, but I'm going to I'm going to try to build just to make sure that there aren't any issues on this side. No issues on this side. Okay. All right. So on this end, we're doing exactly, we're done, pretty much. So we now only know about our delegate that it has this function that we can call. That's the only thing we know about our delegate. Nothing else. We don't know that it has a tip property. We don't know that it has a meal amount text field. The only thing we know about it is this method. So on this end, though, we still have to we still have to do some work. So here's the first place where we have a compile time error. So we're trying to assign ourselves as the delegate. What's our type? Our type is calculation view controller. The delegate type is change tip delegate. So right now we can't do this. So we have to agree to the contract. So this contract that is being created here, that if I want to be your delegate, I have to adhere to this contract. We have to agree to that contract. We are already doing the work, but we're not officially agreeing to this contract in a way that the compiler knows that we're doing that. So how do we do that? By conforming to this protocol. So this protocol name, we can just add, so here we have the inheritance, we can just add a comma, and we can add the protocol conformance. So this should be pretty similar to other languages. If you want to adhere to a protocol, you add it to that type. And yeah, this can be a very long list. And so actually, so Swift has a philosophy called protocol conformance over inheritance. So whenever something can be a protocol, you're supposed to choose protocol conformance over inheritance. So here, inheriting from UI view controller, we're inheriting. So the more Swifty way would be to instead adhere to a protocol. In Swift UI, that's what we're doing. Views are we're not inheriting from a parent class. We're adhering to the view protocol. If you guys remember, we can go over that again when we get there. So so next week maybe. So in Swift UI, there's no inheritance. It's all protocol conformance. So they talked the talk and then they walked the walk. They made all of Swift UI free of inheritance, and it's only protocol conformance. So yeah, this fixed our issues. So our calculation view controller still knows everything about the change tip view controller because we have it as we have access to it as a property here in our segue. It's our destination. We can set ourselves as the delegate because we are saying we are adhering to this protocol. So we're saying we're conforming to it, and we're also doing the work here. If I were to remove this function now, what do you guys think is going to happen? Yeah. So the compiler can now help us. So we're saying, hey, we are a change tip delegate, but we're not implementing the method, so it's not there. So the compiler will now tell us, hey, you're saying you're a tip delegate, a change tip delegate, but you're not. And the compiler knows enough that it can even give us a way to resolve our mistake here. So it can give us the method stub here. So we could go from here, which is pretty cool. All right. So now in our diagram here, when the tip calculator, when the tip view controller communicates back to the calculation view controller, we're going to use delegation, which is a structured way of communicating back to the view controller in a way that we're only knowing as much as we need to know about our delegate. Does this make sense? Okay. So yeah, whenever a view talks back to a view controller, in this case our tip view controller is can be seen as a subview of our calculation view controller. So whenever we're talking back to our controller, we want to know as little as possible about the controller. And one way to do that is through delegation. Okay, any questions here? Yeah. Uh-huh. You can't override anything. So you're just conforming to protocol properties. Protocol methods. Yeah, let's create a little sample project. Let's do excellent question, by the way. All right, so we have a content view here. So content view is a view. So it looks the same way as inheritance. So protocol conformance and inheritance look the same in SwiftUI. The only difference is the color here. Oh, I guess it doesn't even do the color. I think it used to not have the same color. But yeah, so then the only difference is inheritance has to be the first thing. So if we try to conform to a protocol first and then inherit, we're going to get a compile time error. There we go. And it's going to tell us must appear first. So the inheritance clause must appear first. We can fix. It'll just do it for us, which is nice. But yeah, so here it looks like we're maybe inheriting. The giveaway is the view is a struct. Structs in SwiftUI do not have inheritance. So structs only have protocol conformance, which, so yeah, in the Swift philosophy, there's so much right about this. So structs are value types, so we don't have to worry about race conditions and accessing from multiple threads. They're passed as values, so all of those programming mistakes go away. And then we don't have inheritance, which can often, maybe we'll talk a little bit later about why many people propose, they're proponents of not having inheritance, but using protocol conformance instead. I think we don't have quite enough time to talk about that today. But yeah, so let's take a look. What is view? Let's see what view is. Let's go there, let's see, taking its time. Here we go. Protocol. View is a protocol. What's the only thing that a view has to have to adhere to, for something to adhere to the view protocol? The only thing that it has to have is a body property. Let's go back. This content view has just one property, body. So if we were to remove this, so we're saying we are a view, but we're not. So the compiler can help us again. So it's not very helpful. But so the view in SwiftUI as a struct and as a reference type is an abstraction for us, so that we don't make concurrency mistakes, and that we don't have really deep inheritance trees that are difficult to maintain. So behind the scenes, so we're supposed to treat it like this. Behind the scenes, for efficiency and all of this, there are reference types behind the scenes. But like, the nice thing about this abstraction, about this way of looking at the UI is, we now have these contracts with our UI. So views are immutable, which is why we can, why it's going to be safe in a multi-threaded environment. Views are yeah, so I guess that's the main contract is that we don't have to worry about multi-threading. So yeah, but that's for us. That's for us as a mental model for us to be able to not there's no way we can make these mistakes right now, but behind the scenes, what's going on? So what's probably implemented in I think Swift is implemented in C++ if I'm not mistaken. So there are value types. There are reference types. There are the operating system is going to hold onto pointers and stuff like that. But we don't have to worry about that. That's the nice thing about this UI framework. Does that make sense?
Yeah, I guess in this case it probably access certain life cycles.
Ah, okay, very good. So we've barely touched it. So I think I mentioned that this is a view wrapper. So we have so if we go to padding, that's not very helpful right now. Okay, good. So I guess it is helpful. So padding is a function that returns another view. So and we'll go over this in a little bit more detail later. So to add padding to the VStack, we are wrapping the entire view in a new view. So we're kind of creating these onion shells. And one of the view wrappers that we can create is on appear. So this is again, if we go here, we have a function that returns a view. So this is a special kind of view that we can wrap our VStack in that gives us functionality that we can run as the view appears. So it's a very different mechanism. We haven't covered it yet. And it's designed in a way that we can't make multi-threading mistakes, which is very nice. But yeah, we haven't covered it yet. Okay. Any other questions? Very good questions, by the way. Okay. So yeah, we don't have quite enough time to cover the next thing. Let's see. So we have 5 minutes. Let's see. Maybe I'll set up next lecture. So yeah, I wanted to talk about enums. But yeah, let's maybe 100% make sure. Any questions about delegation? So what is delegation? It's a structured way to talk back to our view controller. We want to know as little as possible about our delegate, and then how do we do that? Through a protocol. Our delegate will conform to a protocol, and then we only know whatever's in that delegation protocol, and our actual delegate has to conform to it. Actually, maybe one other let's do this then instead. So we'll do a quick example of somewhere where Apple does this. I think that might be the best use case, so that we can just solidify this thing. So let's create a UIKit app, and let's call it so we'll see table views a lot later on. So table views are pretty much lists of things, and I'm going to do this pretty quickly. I don't expect you guys to necessarily follow this. I just want to show you guys that in a table view is an example of delegation, and so table views are everywhere. So let's take a look at this. So we have our view here. Let's find a table view. Table view. There we go. And so I'm just gonna create those constraints real quick. I'm gonna add it to all of the edges. Okay, so we have our table view. We're gonna have to have an outlet to it. Okay. What's necessary to be for us to be able to talk to it? I guess I slightly mistyped that. Whatever. So I mentioned that it's going to use delegation. So table view is going to have a delegate property right here. So let's take a look at that one. So there's a UI table view delegate. And if we go there, so this is a, oh no, this is it. So these are all properties, these are all functions that are part of the UI table view delegate. So this is where I mentioned earlier this lecture, target action, you can kind of communicate one thing. Through delegation, these are all things the view controller can respond to as the table view changes. So let's go through the motions of hooking this up. So I'm going to assign myself as the delegate. Here I'm going to do it in view.load. So the table view is a view that I have. This is the first place where I can run some code as I have access to those view components. So let's I'm going to assign myself as the delegate. Okay, what's going to happen? We're going to have a compile time error. Why? I'm assigning myself as the delegate. So we're not adhering to the contract, yes. So what was the contract that we have to adhere to? UI table view delegate. Let's do that real quick. Let's add that here. Okay. So actually all of these, so this is a little bit of a behind the scenes thing. So these say optional. So that means behind the scenes is Objective-C. So we don't have optional protocol methods in Swift. We can create default implementations. So this is just a little bit different, and we'll talk about that later. But yeah, so there's one other thing we have to, so there's delegation, but then there's also another form of delegation called a data source. It's pretty much the same pattern, just with a different name. So we also have to mark ourselves as the data source. So same thing here. We have to adhere to this protocol. And here there are going to be a couple of methods that we have to implement. So we're saying we're adhering to this protocol. Let's fix it. So these are the ones that we have to implement. Let's display a couple of strings here, maybe names. And then these are going to be names of our cats. Oh, and we have very little time, but let's see. Percy, Jasper, Geo. We have 3 cats. All right. So how many of these names do we want to show? As however many there are. And then which one do we want to, so we have to return a cell here. We can reuse cells, but we don't have time here right now. I just want to show that this works. And then we can set the cell's text label to the names at the index path here. Oh. Index path dot row. Okay, so this should be able to, we should be seeing a table view with 3 elements here, and so it's 9:45. So you're officially released. So we have a table view now with 3 components. So it uses delegation twice, once named data source. All right, thank you guys so much. I'll be here for questions if you have them.